won't repeat everything that I've said before, but yeah, welcome again to Leipzig Gophers 36. And we are glad to have André Eriksson from Encore here. And André, please take it away.
Yeah, amazing to be here. Yeah, so I think for the purpose of this talk, I've prepared some slides we'll go through and a demo. But I think what's much more interesting, since we're all Gophers, is just to, like, if you have questions, just interrupt at any time. And it's a pretty broad sort of product, so feel free to ask any questions, or we can take it in whatever direction is most interesting. So with all that said, let me share my screen. Oh, yeah. Question if you can mute. Maybe that would be easier. Is the echo gone? I think so. Perfect. Cool. Can everyone see this?
Yeah, looks good.
Fantastic. So this is about Encore, and Encore is a Go platform that we built. I started building this probably 7 years ago by now. Nowadays, we're a company behind it, and a lot of what we do is open source, and that's sort of what we'll go through today. But first, briefly about me. So I'm a software engineer by trade and education and all of that. Started programming in '98 and got into sort of back-end development, if you could call it that, through the web. So ASP, which was this, if you haven't used it, it was this very early Microsoft product for building dynamic web pages. And then if you've heard of things like CGI and Perl, and then PHP, oh, there's ASP there twice, but ignore that. And you could create all these, interactive websites with animated GIFs and all that. That really was the peak of interactivity at the time. And then fast forward a couple of years, and tools like Ruby on Rails started picking up, and Django, where really, and this was around 2004 or so, it really ushered in a new era of how we build, dynamic websites. And that was really exciting because it meant that you could really start to do not just static content, but you could, have users submit data, you could show things, and started building all these sort of websites. And eventually they got me into Python through Django, and that led to me joining Spotify. And so as a staff engineer, I was at Spotify for 8 years, and primarily worked with Spotify Premium, and I was the tech lead for many parts of Spotify Premium. But in the latter years, I was really looking at a lot of things across the company. So a lot of company level technical strategy and so on. I actually built out most of Spotify's sort of initial Go tooling to sort of make it possible to use Go at Spotify. And the reason for doing this is because I wanted to sort of move this giant Python code base over to Go, because Go had much better support for, it was already back then much more performant than Python is, but it was also, type safe. And I started experimenting with, is there a way to just programmatically rewrite Python into Go? And that was a whole lot of fun. And it turns out we didn't actually do that. We didn't rewrite all of this stuff into Go, but nonetheless, I learned a lot about sort of static analysis and parsing source code. and that's been proven very useful with Encore, as we'll see. And after doing that for 8 years, I left and co-founded Encore. So I'm the CEO and co-founder of Encore. So what is it that really changed with the advent of Django and Rails, and why is it the case that they're sort of in decline a little bit? And I think that's because over the last, say, 15 years, how we've developed software has dramatically changed. And so what happened in around 2006 was AWS started becoming a thing. And most of the sort of foundational services that AWS provide to this day were part of the sort of initial suite of services that they launched. And in 2006, that was EC2, which is compute, and S3, which is object storage, and SQS, which is the simple queuing service. So it's a PubSub, effectively. And what this really marked was a shift from, in the era of Django and Ruby on Rails, you were really writing software and putting it on a server. But with the advent of AWS, we started to reason more in terms of services. And that turns out to have a really profound shift on how software is written. So if we look at today, certainly a lot of what we do as engineers is, it's building APIs, it's writing backend services and implementing application logic. But beyond that, we're also leveraging a lot of cloud infrastructure in how we develop software. So it's things like, using databases. It's using PubSub and queues to sort of decouple different parts of the system to make different parts of your backend more resilient and more, better ways of handling errors. Because when you use PubSub, if something is failing temporarily, it will automatically recover once the service is healthy again. And it can really, help build quite scalable and reliable software quite easily. At Spotify, there are PubSub topics and subscriptions with, millions and millions and millions of messages per hour that it just scales perfectly regardless of the capacity, really. Object storage is another of these things. It's, storing unstructured data, a lot of images and video, and anytime you have something that isn't structured that you want to put in a more traditional database, object storage is perfect. And basically, there's from the user's perspective, there's basically unlimited capacity. You can store as much data as you want. You'll just have to pay for it. In terms of money, that is. Caches and CDNs is ways of improving computations and reducing latency and that sort of thing. And finally, what's increasingly common is sort of machine learning models and serving and training models and data pipelines and all of this, which is arguably more than just it deserves more than just a bullet point here, but you get the point. So the way we're writing software is really about leveraging these concepts as much as possible. And this has really been a quite remarkable shift. If you look at 2005, we weren't really doing that. This was before AWS. Most of the code was actually, most of the behavior of your application came from code that you wrote. If you look at how things work today, most of that behavior actually comes from services that you sort of combine together, right? When you use something like PubSub to put data on a queue and then read it, there's millions of lines of code running that under the hood, and it's across multiple data centers and even multiple regions, and it's all orchestrated to make your system more reliable. And it means that in practice, there's the vast majority of the code that your system uses isn't code that you have written. It's not code that you're importing into a library. It's code that's running by your cloud provider. It's executing because they're maintaining these services. And so this is a really remarkable shift. And so what's happened is how backend development works has really changed. And a lot of this is in the service of making things, more scalable and more reliable. And we really learned to build software that serves the whole planet. If you look at products like Google or Facebook, they have billions of users. It's like a significant percentage of the whole world. And that's only possible by using these really, really scalable and reliable cloud primitives to structure your application. And perhaps not only for the better, some of the tools that we're going to look at are they help us do this. So this is the Terraform as an example. And they are really powerful, but they also maybe don't provide necessarily the best developer experience for how they work. And that's really where I see that we can really improve on how we build backends today. So let's look at how typically Terraform works. There are other tools other than Terraform, things like Pulumi, and AWS has a thing called CDK and so on. But fundamentally, they sort of work similarly. And so what we're looking at here is a code snippet for using a pub/sub topic and a pub/sub subscription using Google Cloud Platform's official library. So this is the use case, right? We have a backend, and we want to publish a message on a pub/sub topic, and then we want to have a subscription, and we want to read that message. And so what you see here is we first create a client, we pass in the GCP project ID, then we create a topic, which is just a reference to a topic, and we pass in the topic ID, and then we can publish data. And then later down here, you can see that to create a subscription, you do the same thing. You get a reference to a subscription, you pass in the subscription ID, my subscription in this case, and then you can begin to receive messages. And if you look at this, you could say, well, I mean, that looks pretty simple, right? And it is, but looks can be a bit deceiving. When we're looking at Terraform, on the other hand, to actually create this, what you see on the left, to actually create this cloud infrastructure, we can use something like Terraform. And to do that, you write a bunch of Terraform, which is like a different language. You learn it, and it goes well. So here on the left, you can see an example of that. So you create a Google project, or you enable the pub/sub service in your project, and then you create a pub/sub topic, and then you create a pub/sub subscription, and then you're done, right? I mean, it also looks pretty simple. So what's the problem here? The problem is this is just really the tip of the iceberg. And when you look at sort of Terraform examples, oftentimes this is what they show you. It's, create the topic, create the subscription. But what's missing is a whole lot of stuff. It's you need to create a service account to be able to publish messages. And then if we go back here, the publisher needs to use that service account and authenticate with it to be able to publish. So you need to create a publisher service account. Then you need to grant that service account permissions, and it needs to be granted publishing access to this topic. Then you need to do the same thing on the subscriber. So you need to create another service account, and then you need to grant that service account subscription rights to the subscription. And then you need to make sure that the subscriber is using that service account. And then we haven't really gotten into any actual configuration of these topics or subscriptions. If you want to do things like specify retry policies or message ordering or concurrency or anything like that. And then if you want to do something like create a dead letter topic, which is a very common way of sort of handling errors, where if a message cannot be received because it keeps failing, eventually what you want to do is you want to put it off to the side so that you can inspect it and figure out what's wrong with this message. And that's called a dead letter. And then you can put it back into the main topic once you've found and fixed the bug that caused it to not be delivered. But it turns out to have a dead letter, you need to grant the dead letter topic permission to subscribe to the subscription, because that's sort of how it works under the hood. Is the dead letter topic needs permissions to do that. And then you need a subscription on the dead letter topic to prevent the message from being deleted. So there's a lot of sort of, it looks very simple on the surface, and then there's a whole lot of stuff that you have to do to build something that it works in practice, and it's secure and sort of with all the best practices in place. So if we go back to the Go code, this looked good, right? Well, not so fast. So if we talk about, all of these are hard-coded string constants. And that's not very good, because if you actually want a test environment, all of these will be different from your production environment. And we don't want to hard code a bunch of production IDs into our code base. So what we need to do is we need to replace all of that with configuration. And then we need to go from all this Terraform code, and we need to define outputs, and we need to export all of the IDs the Terraform provisioned, and then we need to inject that into this configuration. So in summary, the way you build, and now we're just talking about a very simple thing, which is defining a pub subtopic. There's a whole lot of Terraform boilerplate. There's to actually, we have just scratched the surface on how to do this in multiple environments, because then you need an entirely different cloud infrastructure for if you want like a development environment in the cloud. And then you need different configuration for every environment. And then if you actually want to run this locally, you need an entirely different setup yet again, because you can then use something that's called like a pub sub emulator, but then you need to configure that differently, and so on. And all of this is extremely GCP specific. It works very similarly if you want to use AWS, for example, but all of the code we've just looked at is specific to GCP. If you want to have an AWS setup, well, suddenly you need different Terraform resources, you need different libraries in your Go code, and so on. And then if you want to use yet another cloud, it's the same thing. So you get very locked in very quickly to your cloud provider of choice. And we touched on this a little bit, but if you actually want to do anything beyond just running it, you also have to sort of, do a whole lot of mocking and sort of be able to actually unit test or integration test this code. There's even more work that we haven't even gotten to. And perhaps what's most worrying of all is how to actually make this secure is extremely laborious. And it means that security is sort of an afterthought. If you want your cloud infrastructure to be locked down to the point where services only have access to the right infrastructure, and all the infrastructure is configured accordingly, according to sort of best practices, that's typically even more work. And that means that a lot of the time it sort of gets ignored, and you go for something that's, it's okay security-wise. And it's not great where making something more secure is more work, because it means you don't really do it in practice. Now, that's Terraform. Another tool that we all, and I mean, don't get me wrong, like we use Terraform a lot. It's great for what it does, but it's not a very productive developer experience. Now, for another tool that I sort of have a similar relationship with is Kubernetes, which a lot of you probably use. And Kubernetes is great. It's extremely flexible. It's extremely powerful. It can be very reliable if you set it up in the right way. But for anyone who's ever used it, you get a very deep hatred for YAML, typically, over time. So what you see on the screen is I pulled up, so from the Q project, I pulled up an example, like sort of hello world application with, I think, 3 different microservices. And I took all the YAML and I put it on the screen. And this is a very simple backend application. And this is the amount of YAML that you have to write. It's an extreme amount of repetition that basically looks the same for everyone. And in fact, I'm lying to you, because it didn't even fit on the screen. So here's even more. And so that's sort of the state of modern cloud backend tooling. It's fine. I don't know what to tell you. It's fine. So this is sort of what we're trying to get away from with Encore. So what Encore does differently is, in contrast with Terraform, the way you write application logic in Encore, it's purely declarative. And the idea is the whole application should be declarative. So what do I mean by that? I mean that instead of having infrastructure concepts that you sort of manually execute and then have to use Terraform in a separate code base to manage the infrastructure, with Encore, it's all in the application code itself. So we'll go through a couple of examples just to give you a sense of what I mean by that. So on the screen here is how you define an API endpoint with Encore. And you will see that it's really just a normal Go function. The only difference is there's this annotation which tells Encore that this function should be exposed as an API. And in the path parameter, you can see there's like a name parameter, and that corresponds with the name parameter on the function. And then it's just like a normal Go function. You can define the type same as you would with any other Go code. And when you run this with Encore, Encore will actually take this and it will generate all the boilerplate to make this actually work as an API. If you look at defining a database, it's the same thing. You import a package. In this case, it's encore.dev/storage/SQLDB. And then you can just assign to a local variable the result from this function call, SQLDB.newDatabase, and you can specify the name of the database and where the migration files are. And then you can just start using it. There's no need to do any sort of Terraform. There's no need to copy any configuration. It's just add these 3 lines of code, and then you can start using the database. And under the hood, what Encore does is it parses the source code. It finds all of these, declarations of, creating a database, and it uses that information to actually provision that database. And that works locally. It works when you're writing unit tests. It works when you're deploying to the cloud. And the same code runs anywhere, basically. We looked at PubSub before, and this is Encore's version of all of that. Same thing as before. You just call pubsub.newTopic. You pass in the type of message that you want to send, and then the name of the topic, and then you can just start publishing messages to it. Encore will automatically provision this into GCP, for example, but it will also manage things like dead letters, subscriptions, IM, all the security aspects, so that what you see on the screen is really all you need to do. And similarly for, caches and cron jobs and secrets, it's all about, how can we make this declarative? And by being declarative, the static analysis of Encore can parse this and understand how it all fits together. And so when it then comes to actually how this works, just to give you a sense of how this all fits together, what I just shown you is this application code infrastructure SDK in the top left. And that's how you write code with Encore. And then Encore will automatically manage local development. So it will set up all the infrastructure on your computer. And then when you push to GitHub, for example, or whatever you use, that integrates with Encore's platform. And that platform, it does a bunch of things, but most notably, it will automatically create dedicated environments for every pull request. And then it will provision all this infrastructure into your own cloud provider. So all of this will then go into your own cloud provider where you control all of the infrastructure. And because the application code itself is cloud agnostic, there's much less lock-in. If you want to move from AWS to GCP or the other way around, you can create a new environment in the other cloud with a click of a button. And Encore knows how to translate all of this infrastructure between cloud providers. So the benefits: no configuration, basically no boilerplate. It automatically works in all environments. There's first-class support for local development, as well as unit testing, integration testing, system testing. Security and sort of least privileges, security best practices is baked in from day one. So you never have to think about, are we setting all of this up in a way that is secure? Does this match sort of the AWS best practices or anything like that? And there's no cloud lock-in because you can very, very easily move between cloud providers. And maybe most of all, even if you're using Kubernetes, you don't need to write a bunch of YAML. So with that, I figured we should jump into and show how the product actually works. So let me do that. So this.
Can you just make it a slightly bit bigger, please? Yeah.
Is that good?
Yeah. I think it's better.
Even big. Cool. So what we're going to do now is we'll create an application. For the purpose of this, I'm going to start with one of the built-in templates, just so that we have something to look at. And I'll pick this, which is an uptime monitoring system. And there are a couple of Go microservices. There's some databases, there's some pub/sub, and some cron jobs. And there's a front end written in React. Oh, demo. Set this because I'm running a development build. Let me do that again. There we go. Cool. So now with this, Encore has created this application. It's connected it to the Encore platform, and it's told us, how do we actually run this thing? So we're going to go into this, and we're going to type, as it suggests, Encore run. And immediately you can see Encore starting up. It will do a bunch of static analysis. It will understand how do all the services fit together. It will create a bunch of databases. It will start up pub/sub. It will fetch all the secrets, and then it will generate a bunch of boilerplate, and then it will compile the application. It will run all the database migrations, and it will start up the application. And all of this happens in just a couple seconds. The first time you do it, it's a bit slower. But if I do it again, you can see that it's very, very fast. And this is with 3 services, a front end, a bunch of infrastructure. And now it's all running on my machine. So let's try to actually call this project and see how it works. And to do that, we can start by jumping over to the Encore development dashboard. And this is built in to Encore. So you click here, you get taken to the local dashboard. And here on the left, you can see all the API endpoints that exist. And we can take one of them. So this one, for example. And here you can see that to call this endpoint, you make a post request to this URL. And the payload looks like this. Add Hacker News like that. And I hit call API. I get the response. And on the right-hand side here, I get some traces. So I can click into one of the traces, and I can see exactly what this is doing under the hood. So here I can see that the first thing that happened is it made some database queries. I can see exactly what are those queries doing, if they fail, if they complete, and so on. And then finally, there's a pub/sub topic here that the application published to. And here I can see that this published a site added message, and this was the message contents. I even see that there is a subscriber here that processed the message. So I can click on that. And this will then take me to the other trace where this message was processed. And here we can see that this other service actually reacted to a site being added, and it started checking, is this up or not? So in this case, it made an API call. We can go into that. And this made an API call to the ping endpoint. We can click on that. And here we can see that finally the monitoring system, it actually made an HTTP request to Hacker News website. So all of this is sort of automatically instrumented by Encore. What you do is you just write business logic. And what you get is things like, API documentation. You can see all of the different endpoints, what are the parameters, what's the request, what's the response, and so on. You also get architecture diagrams. So this is also based on the static analysis that Encore does, where because Encore understands how all of this fits together, you can see what are the different endpoints, what are the different services, and what infrastructure do they all have. So in this case, this is one microservice. It has 4 public endpoints, no private ones. It has a database, it has a cron job, it's making API calls to this other service, and it's publishing messages to this PubSub topic. So when a website goes down, then the Slack service will pick that up and actually notify you on Slack that, hey, this website is down, you better check that. So let's look at the code. How does this actually work? And so we'll go back to the terminal. We'll close this for now. We'll open it up in VS Code. You can see that what I did here, it obviously generated a bunch of API calls to my local, locally running service. So here you have the 3 different backend services that we talked about, as well as a frontend. And if we open up the code, you can see what we talked about before. I'll make this a bit bigger. So with Encore, everything is declarative. So the way you define an API, it's just a normal Go function. And you can specify whether it's public or private. You can specify the HTTP methods. You can specify the path, and so on. If we go down here, actually, let's open up this one instead. So what you see here is an example where you have a path or a payload to the API. So this is a REST API to actually add a site to be tracked by the uptime monitoring system. And here you can see that this takes in a URL. And this was the endpoint that we called ourselves, but we can very easily add in another field, and then we can type Encore run again. And now if we go back to the documentation, head over to this, you can see that the documentation has been updated. Now let's say we want to do something more interesting. Let's say that we want to add, let's use PubSub again as an example. So here's a reference to how you can use PubSub with Encore. So we'll copy this code. We'll define our own event type. Head back to the code and head down to the bottom. So here you can see the infrastructure that is already in place. So here we've defined a PubSub topic, and this is the topic that gets published to when a site is added to the system. You can go in and say, site deleted topic. And let's just reuse this and say site deleted. Hit save. And as soon as I hit save, Encore recompiles and restarts the service. I head back to the architecture diagram, and now we have a new pub subtopic. And then I can go back and I can find the endpoint in question that actually deletes things. And I can say, I do this. I'm not an expert on Gorm. But it's not ideal, but I will just do it to demonstrate. So when we call delete, we will first get the site, and then if that is successful, we will call site deleted topic, and we'll call publish like that. If that fails, we'll return an error. A typical, in a more realistic example, you might do this in a database transaction and so on. But for this will do. So I hit save, it recompiles, and now you can see that the site deleted topic is being published to by the service. So now if we go in here and we go to site delete, and we can pass in number 1, open this up, and you can see that first we query for that site, and then we publish a message on this new topic. So that's sort of how easy it is to use cloud infrastructure in this way. And when you want to do things like, for example, we head over to the monitoring service, to actually make an API call to another service, you simply you import the other service because it's just a Go package, and then you call the function that represents this API. So in this case, I call site.get, and here you can see that Encore has actually generated a sort of placeholder method to serve as a way to call this endpoint, and this gets automatically updated by Encore when the signature of that endpoint changes. So API calls in Encore, they look just like function calls, and under the hood, they get compiled down to actual API calls. So the real benefit of this approach is, if I try to pass in a string when this should be an integer, this will not compile. You'll see that you try to pass in an untyped string when it should be an integer. And here in the code here, you can actually see that this has been rewritten by Encore to be an actual API call. So this is how it works under the hood, is this gets rewritten into a separate implementation that actually performs the API call. That's how you can minimize boilerplate. So once we're happy with this, we can take this, we can do git add. We'll add a commit message. Here, these are the changes. So in just a couple of lines of code, we've modified an API endpoint. We have added a pub subtopic, and we've started to publish to it. And now we can actually deploy this to the cloud. So I'll do git push Encore, and that will take us to Encore's cloud platform. In more realistic use cases, what you would do is you would instead integrate this with GitHub or whatever. But this works fine for a demo. And over on Encore's cloud platform, there's built-in CI and CD that will compile it. It will run all the tests and so on. All of the infrastructure is automatically available with sort of test optimized infrastructure. And then once the tests pass, Encore will automatically provision all the cloud infrastructure that this application needs. And once that's done, then it will deploy it to the cloud. So we'll give it a couple seconds to actually go through, and since this is the very first commit, it's a bit slower because there's no build test cache or build cache yet. But for subsequent deploys, it tends to be much faster. So now that the build step is done, Encore automatically creates all the infrastructure that we need. So here we can see all the pub/sub topics, the databases. Here we can see the site deleted topic that we talked about. And then as soon as the database is ready, all of the infrastructure is done. So this takes typically about 30, 40 seconds. Now it looks like GCP was a bit slow to create the Cloud Run service. So under the hood, this runs on GCP. And then it will deploy the latest release, and then the application will be up and running in the cloud. So now it's up. The deploy is successful. We can head over to the overview here. And here you can see that we have a ready URL that we can open up. Let's do that. We'll head over to the front end. Obviously, there are no sites here because this is a fresh environment, but we can go ahead and add them. So this is a fully working, cloud backend that's been deployed. This is currently running on Encore Cloud, which is the Encore provided sort of free to use hosting for hobby projects and so on. But for a production environment, what you would do is you would go in here, create a production environment, then you would connect, say, GCP, and then Encore would do the same thing, but for your own GCP environment. And then you have all the infrastructure, you can tweak it, you have tracing, all the metrics. This also integrates with things like Grafana and Prometheus for sending metrics data over there. And yeah, you name it. There's everything that you expect. API documentation, tracing, code browsing, architecture diagrams, etc. So this is sort of how Encore's developer experience improves on Terraform in particular, where by making cloud infrastructure part of the source code, it eliminates a lot of the problems that you have with Terraform. And it makes for this really, really productive developer experience where you can really just write Go code and then keep shipping instead of having to go back and forth between code and Terraform and configuration and mocking and all this stuff. So maybe I'll stop here. If there are any questions, I'm of course happy to answer them, and then we can also dig into like how all of this works under the hood, because there's a lot we can get into depending on what people are interested in.
Yeah, thank you very much. I think yeah, I mean, I had to mute the mic, so you missed some laughter when you showed the YAML slide. I'm sorry for that, but you can imagine. Yeah, I think it was an amazing presentation. I think probably you made some people miserable who work with cloud infrastructure every day. As for how different a world this can be. So yeah, I have a couple of questions, but I'm not sure. Like, people have impressions or questions, or otherwise I can also start. Yeah, just I start with some things. Yeah, so first of all, it's quite all very quite amazing in terms of developer experience. And I don't use the cloud personally, but I fiddle a lot with other kind of infrastructure things, and certainly, yeah, this is very nice. I wonder, like a lot of cloud providers, of course, they expand. Like you mentioned the first key services at the beginning. But of course, they're like, I'm not sure like what the exact count is. Other people can tell this, but there are hundreds of services. And so this creeps into companies, and you stay quite focused with your project at the moment, or like it looks like you have a very clear focus, which makes it really very, very usable. Did you encounter the point where you said like, okay, we have to say no to some of the things, we cannot abstract everything? And was there like, I imagine you have to say no at some points. And how do you decide that? Or did you have to say no? And how do you decide that? And how do you keep that kind of focus, which shines clearly through? As a first question, just as a general question.
Great question. I mean, I think even though I spent a lot of time talking down on Terraform, one of the real huge benefits of Terraform is the breadth of all of the different services that are available. Oftentimes, if you look for PubSub examples with Terraform, there's a lot on the web. If you try to search for, random AWS service number 374, there's almost no documentation. And, in practice, in my experience, there are use cases where AWS service number 374 is exactly what you need. And when that's the case, because Encore integrates with your own cloud, you can keep using Terraform for that like 1% of the time. There's nothing, stopping you from using Encore together with other tools like Terraform. But in my experience, when it comes to business logic and how you write, modern cloud backends, you come back to the same services again and again and again. So I think the services we went through in this talk, PubSub, databases, caches, cron jobs, secrets, object storage, etc. That's like 95% of the use cases. And then you add on like a couple more, and then you're up to 99% of the use cases. So it is true that Encore will never have, bespoke integrations with every single AWS service, but there's nothing stopping you from going outside of Encore to use that, because at the end of the day, it's just normal Go code. The way you would do that is exactly the way you would do it today, and then Encore can make the remaining 99% hopefully much better. So that's sort of how we see it. Is we will add support for more services and infrastructure over time, but you always have the option to use other tools when you have like a specific use case that isn't covered by Encore. There's a lot that we haven't really gotten into in terms of configuration. If you want retry policy in Encore, it's all type safe. So you can just do this and then retry policy, and then you can see exactly what are the fields. So then you can just do this, and then if you deploy this, then Encore will update the infrastructure. So you still get a lot of the flexibility that typically you would use Terraform for. But yeah, I think that's sort of how we're approaching it. Obviously, you can't support every single AWS service. In practice, in my experience, you don't really need to, because most of them are very rarely used, and they are, hyper focused on like a very niche use case.
Yeah. Thanks. I think other people can comment better on that, but it's good to see that you can just mix and reach out to other services that are not covered by that. Some other questions that I had was the static analysis part, which is nice, and you mentioned that you used some transpiling from Python to Go at the very beginning. And can you describe, is it the experience parsing Python versus parsing Go, and is Go does it support everything that you expected? I haven't done this extensively before. I just know a little bit of the parts that go into that. But what was your experience? Maybe.
Yeah. Great question. So I just opened up. I don't know how to zoom in. What? How do I zoom in? So this project is Encore's. This is the Encore project, and you can find this on GitHub. It's github.com/encoredev/Encore, and this project is, let's see. It's 121,000 lines. So there's a lot of complexity that goes into everything Encore does. So I can't walk you through all of it, obviously. But fundamentally, if you're interested in digging into this, it should be fairly well documented. Most of the static analysis happens inside this V2 project. And you can go into the parser, and let's see here. Sorry, it's internals, package info. This is there are many parts to the static analysis that Encore does, but it very heavily relies on the Go standard library. So there's things like Go build, Go token. There is Go packages, which is part of the extended standard library. A lot of the work around sort of name resolution is using the Go ASD packages. So the big difference between parsing Python and parsing Go is that Go has excellent support for static analysis. When I was parsing Python, I actually had to build, because I wanted to do it in Go, I had to build my own parser that was sort of parsing Python's syntax and all that. So Go, in comparison, is a breeze. A lot of what this code looks like is, let's see if I can find it. A lot of what this code looks like is, it's basically if when we're parsing a type, it's here. We basically have Go representations for different types of the Go language, and then the way it works is you get an AST expression, and then we have a lot of these switch statements where we're trying to figure out if this is a star expression, it means that this is a pointer type, and then we sort of recurse into the next thing. If it's an identifier, then we sort of look up, is this a type parameter? It's a lot of sort of very fairly repetitive code actually to do the static analysis. Go has tools to do more of this for you, but for Encore, it's designed to be extremely fast, which means that we're not using a lot of that because it's duplicating a lot of the work that the Go compiler is doing right after Encore runs. So as you can see, when you type Encore run, I don't know if you see how quick this is, but when this completes, that's when Encore has completed its parsing. So it takes 50 milliseconds or something. And then the compiler takes over, and that's just a Go compiler, and it's much slower than when Encore does its parsing. So to make that as performant as possible, we're not using a lot of the sort of higher level Go packages that provide it does a lot of the type checking for you. But the downside with that is it is sort of duplicating a lot of the work that the Go compiler is doing right after. So in the name of a productive experience, Encore is not using a lot of that. So that's why it's very, very repetitive, or we're repeating a lot of the work that you can otherwise do. And then if we look at PubSub again as an example, this is the code for Encore to parse PubSub. And here we can see we have a representation for a PubSub topic. And here's how we pull out all the different properties and configuration options. And basically, the way it works is we look for certain imports, and that is an optimization so that if a file does not import this package, we can just skip it without having to parse it at all, because we know that this file will not call new topic at all. And so there are a lot of those sort of optimizations that you can do. And then it's sort of parsing the syntax tree to understand, what are the different types involved and so on, and decoding all the configuration and so on. So it's a lot of code, but still parsing Go code is so much better than other languages.
Yeah, I remember that that was somewhat also the goal, or like mentioned at one point, that Go should be easy to parse for programs. And I mean, Encore is a complex program, but it parses your code and generates something else. So I think it's quite interesting how deeply it integrates with some of these ideas that the Go language also brings with it. Yeah. Just a last question for me before. I mean, I don't want to talk just all the time, but you have the public cloud providers. Some people run on-prem cloudish environments. Do you have any plans for that, or is it something on your radar?
Yeah, no, I think it's an extremely important use case, and I think it's becoming more common. I mean, there are a lot of legacy applications that are moving to the cloud every day, but there's also, the cloud is expensive. It gives you a lot of value, but it's also very expensive. And so there's a lot of sort of movement to sort of hybrid workloads where some of the stuff is cloud, some of the stuff is not. And I think with a lot of sort of, especially if you work in more sensitive environments, whether it's finance or health, or there's also concerns, particularly in the EU, around sort of using the public clouds in a way that is compliant with the GDPR and all of these data protection regulations. So it's a super important use case, and we're actually what we're working on is supporting using Encore with your own Kubernetes cluster. So instead of Encore, using a cloud Kubernetes cluster, for example, you will be able to integrate it with your own Kubernetes cluster, even if that's like an on-premise cluster. And then Encore can provide a lot of the same sort of nice to haves in terms of deployment and orchestration and all of that. But then on the infrastructure side, you can sort of decide, do we want to use cloud infrastructure for this, or do we want to use our own sort of self-hosted versions? So with PubSub, for example, a lot of people use Kafka or Nats and so on. So I think that's very much where we're going, is providing the same experience, but it will work both with on-premise workloads, cloud workloads, or anything in between.
Yeah, great. And that sounds good. And is since your part of your project is open source, would that be something that people could like work on the open source part? Like if they look at your source code?
Yeah.
Yeah.
Absolutely. Okay. So a lot of the basically pretty much everything I've shown you in terms of like all the code that's running inside of your system, the compiler, the parsing, the static analysis, the CLI, all of it is open source. So a lot of what's needed to support on-premise workloads is sort of more infrastructure integrations. So if we use PubSub again as an example, this is the Encore runtime. So this is all the code that Encore uses at runtime to provide like implementations for all the different infrastructure concepts. So in the context of PubSub, you can see here all the different types of providers that Encore supports. And they're all sort of build tagged for performance. But GCP, for example, it's located here. And you can open up the GCP topic. And basically, these are implementing an interface. So let me see if I can find where that interface is. Here. So basically, this interface is what needs to be implemented to support a new PubSub provider for the topic, and then obviously there's a similar one for the subscription. So publish and subscribe. So to support GCP, for example, we've written this implementation, which is essentially using the very same PubSub libraries that I showed on the slides, where this is just making API calls to the same library that you would do it yourself. And so to add support for something like Kafka for sort of on-premise PubSub, the main piece of work is to just add a Kafka implementation, implement all of these in terms of Kafka, add a Kafka provider, and then Encore understands how to integrate with Kafka. So a lot of that work is we just haven't gotten around to it because of time constraints. But obviously, contributions are extremely welcome if it helps you in using it in whatever setup you prefer.
Yeah, it's very, very nice to see that modularity, and anyone else has questions? comments?
Yeah, maybe. Oh, wait. Okay. That's still a little bit of feedback.
Okay, it's Noma.
Okay, so second try.
You can mute yourself and use the mic here. It's a little bit weird. Okay. This is the mic here. But yeah, it should be.
Can you hear me?
Yep.
Okay, great. So my question is mainly about integration with existing infrastructure. So I've seen the developer dashboard you showed, which is pretty great because it, gives you like a lot of insights about the application for free, like tracing, metrics, and so on. I was wondering, let's say I'm working on an API and I want to, or my company requires me to expose like an open API spec. So the developer dashboard also provides me with an API specification, but is this under the hood reusing like existing standards or something that I can just expose? Yeah.
Yep. Great question. So all of this is sort of it's powered by Encore's static analysis, right? So what you can do is you can Encore has a command called Encore gen client, and with this you can specify like from which environment. So we'll say local because I want to do it from my machine, and then I want to say give me a TypeScript client, and then Encore generates a fully type-safe TypeScript client. You can also do client.go, obviously, and then you get a Go client. And what you also can do, even though it's not a client per se, but it's the same sort of setup, is you can generate an open API specification. So with that, you get an open API specification for your API. So that's already supported. You can see if I go back to the open source project, all of that is also open source. So you can see here in the client generation, you have the open API language, and here you can see how all of that works, where we're basically taking what's called the Encore metadata, which is a protobuf with all of Encore's static analysis, like what are the different services, what are the endpoints, what are the different infrastructure, and that's what it's using to generate all of these things, whether it's Open API or Go or JavaScript or TypeScript or whatever. So yes, it's already supported. It's also completely open source, so it's easy to add more languages if needed.
Thank you very much. That's pretty great. It's already integrated. Maybe if I can iterate on that question, how does it work for tracing and metrics? Like if I, for example, have an existing Grafana and I want to, basically scrape the metrics from the application.
Yeah. So what you can do, you can just head over to the cloud dashboard, connect Grafana, add your stack, specify your API key, hit save, and click here, click redeploy. On the next deploy, Encore will enable the Prometheus integration. So then it will push to Prometheus. And then these dashboards will automatically update to fetch data from Prometheus. So all of this data is not actually hosted by Encore; it's fetching it from your cloud provider. So you have full control over all the data. All the Prometheus stuff also open source. You can go in here. You can see all the export code, how it's integrated, how it fetches all the time series, collects everything, and exports it. So should be easy to use. I hope.
Well prepared. Thanks again.
It's almost like I prepared you to ask questions where I could just say like, yeah, that's done.
Yeah, it's really amazing project. I mean, you have been working for a couple of years on this project, but it's
Did
really.
you sleep?
The question is, did you sleep in the past 8 years?
Sometimes.
Yeah.
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 No, I mean, I'm fortunate that it initially started as just me building this for I think 4 years before but now we have a bunch of we have a whole team building this, so that's very fortunate that we can build something like this that we're getting a lot of positive feedback about. There's a lot of people who really like it, so it's great to be able to do it and to do it open source too, where we can just get people's feedback and show the world how it works and build something that's hopefully quite compelling and useful.
Definitely.
Can I ask another question?
Okay, let's
okay,
one more question and then we stop the recording.
Okay, yeah. It's not necessarily like about Encore directly, but since it's a larger application, larger Go application, and I mean, we are all here like interested in Go and like Go, but did you face any limitations of the language where you say, hey, I would wish for like this feature, for example, like we would love to have enums or union types or whatever in Go. So is there anything that you think is still missing from the language?
Yeah, I actually think like I think enums and sort of more, particularly when like in terms of writing all of this, there were a lot of features that we sort of waited on generics to support. So examples of that is like PubSub is an example. Like you can't do this without generics. So we were waiting for several years to add PubSub support because it was like generics is coming. We're gonna wait for that so we can provide a nice API. I think and we actually use generics a lot nowadays in the implementation of Encore, and like a lot of this code is using generics. I was fairly sort of ambivalent about generics before. Now I actually really like it, and I think it was a good addition. What is a bit frustrating, it's maybe not in terms of how we implement this, but in terms of using Encore, where I actually wish there was better support for enums, for example, because there is no good way. Like if you want to have, let's say that in the add API definition, like if you here want to say like you can specify URL or something else, like something like Rust's very powerful enums. It's not like a traditional enum where you say like it's I don't know, site type string. I mean, this is a type of enum. This is a type of enum, but what Rust does is, for example, you can have different options, and each option can have different data associated with it. So I feel like when you're using Encore, sometimes Go's fairly limiting type system can be a bit awkward. We are working on gRPC support, and then you can just use gRPC if you want more control over like enums or one-offs or anything like that. But in terms of the language, I think generics was a really big one. sometimes I wish there was better error handling. I actually am a really big fan of Go's error handling, and I don't want exceptions. But there's a lot of this, right? And there's a lot of like wrapping errors that I think it makes for reliable code, but it can also be a bit painful. And there's been several times where I've like prototyped something and just ignored error handling because it's like gets in the way, and then to make it production ready, I've had to go back and like add error handling afterwards, and that's probably a sign that it's like it's a bit too painful sometimes if you're too lazy to do it the first time, right? Yeah, maybe a long answer, but good question.
It's fine. Also an answer that I mostly agree with. Not that this makes not that this has any relevance if I agree with it or not, but I felt like the same issue. So I also would love that enums would be a part of the language, and I also agree that generics, even though people were like skeptical about them, are actually added in a way which made them not too complex, but still very useful.
Yeah.
And about the error handling, I mean, there were several proposals, and not sure if you have followed any of them, but I guess that let's give it like 1 or 2 years, and that's my assumption that we then actually, or one of those new proposals will get accepted, and we get at least a bit of like convenience stuff to make that more easy to work with. But I also agree with you that the error handling as it is cool in its explicitness. So I'm right now working a lot with Python, and I would love to have explicit errors instead of exceptions. So that's something I do miss. Yeah. Anyways, thanks for the thorough answer. Yeah.
I feel like we are all we could all use a break, but I just want to ask a last question from someone who is not here, just to get this last question out. I think we covered some of them. Just read it. Is it possible to forward traces to an open telemetry collector? I think we kind of, I'm not sure like whether we talked about that, but we have the like Prometheus and Grafana integration. I think we can leave that. Is there a way to access the Encore database externally, or at least view the data? I try to answer this question. I mean, you can run everything locally, and when it runs locally, you'll have a whatever database is beneath that, Postgres or SQLite or whatever. So it should be visible.
Yeah, you can also there's a command called Encore DB shell, and then you can specify like I want the local database, and then you get a shell to that. You can equally easily say I want a shell to the cloud database.
Yeah, I think that covers this question. And the last question is there a possibility to access the Encore broker externally? I don't understand this question exactly.
So broker, it could be like the PubSub broker.
Yeah, probably. Yeah, maybe the question is whether a third-party application can hook into that, probably.
Yeah, probably it depends a little bit. If you are deploying to your own cloud, then you can very easily, like the PubSub topic or whatever it's in your own cloud. So of course you can access it and do whatever you want to do with it.
Yeah.
When you're running locally, it's harder because Encore, as we saw, it supports a bunch of different PubSub implementations, right? There's AWS, Azure, Encore Cloud, GCP, NSQ. There's a testing implementation. So it's difficult for Encore to sort of expose that, because it means that any other service would need to be aware of all of those implementations. What tends to be easier, for example, is to expose an API for other services to use. Like if you want to say like publish says, like this, for example.
Yeah. Mm-hmm.
And then you take the PubSub and you make it a Go API endpoint. So if I do this, I hit save, then I get an API endpoint, and then you can just call this to publish to the topic, for example.
Okay. Yeah, I think that should cover this question. Yeah, thanks. Okay. All right. I would say I just stopped the recording. It doesn't mean that the meetup ends, but thanks a lot for the presentation and for this project. And I will write a short wrap up about the meetup and include some more links because I think it was really interesting, and at least people should look into that and just kind of if they experience some of the cloud pains. Okay, I just stopped the recording. Stop recording.